Okay, let me show you how to use your GDC to work out normal questions, all right? But before I show you this, let's do a quick recap. So the normal distribution is a distribution which is continuous, so it can take both exact values and decimal values, and it has a mean and a variance defined in the distribution, okay? So this is read as x follows normal mu sigma square, all right? Where the mean is the mu and the variance is sigma square. So if you need to find standard deviation, you do square root of that, and that becomes the standard deviation. So let me just write that. So sigma square is the variance, and sigma is the standard deviation, all right? And mu is the mean of the distribution. And it's usually it has a bell shape, and it's symmetrical around the mean, mu. So the shape is something like that, where the mean mu is in the middle, all right? So that's also referred to as the bell shape. So let us try to do a question now. So let's say we have a normal distribution, okay, with a mean of 50 and a standard deviation of 5. So if they tell you the standard deviation is 5, you need to realize that they're referring to sigma. So in the distribution, when you write it as sigma squared. So let's say we need to find the property that x is, let's say 52, okay? So we're trying to find the property that x is equal to something. Now, when we're trying to work out x is equal to a number, on the calculator, we need to choose the distribution which fits that question. So what we do is we press on menu, and then we choose the stat menu, execute, and then you're going to go on distributions. So that's F5, and then normal is the first one here. So you're going to press on F1 to get the normal distribution. Now it gives you three different options. It gives you NPD, NCD, and then inverse normal. So here we're working out x equal to a number. So that's NPD. So every time you need to work out x equal to something, it's NPD. Then once you go in the menu, once you are here, the data is a variable because we're not choosing values from a list. X is the value we are calculating. So here it's 52. So x will be 52. And then the sigma, for us, the sigma is standard deviation, so that's a 5. Sigma 5, then the mu would be 50, so 50, like that. And once we've entered all of that, we just need to go on execute, and here you go. So it's 0.0737 if we need to give to 3SF, okay? So it's going to be, answer is going to be 0.0737, okay? Because it's 7365, so because of the 5, this is going to be rounded up, so 737. So we use NPD, okay, when we have x equal to a number, all right? Now, let's say we need to find the probability that it's between two values. So let's say it's between 45 and 55, all right? It's between two values. So I'm going to exit. Same thing, distribution, normal. But since it's between two values, it's not x equal to something, I'm now going to choose NCD. So NCD allows you to put values in a range, okay? So you can see here, it's asking me for a lower bound and an upper bound. So the lower bound is 45, it's already there on my screen, so I don't need to type it. The upper bound is 55. The sigma is 5, all right? And the mean is 50. So I've got everything on the calculator already. I just need to go and execute. And here you go. So this one will be 0.683 because the 6 is going to round up the 2, all right? So that one is going to be 0.683 to 3SF. Now, let's say we need to find the property that it's it's greater than something. So let's say it's greater or equal to 54. All right, let's do this one. So exit, go back, distribution, normal. It's still NCD because it's a range, it's not x equal to something. I'm going to choose NCD. So it's variable. The lower bound is 54 because it starts as from 54 and then it goes up. All right. So the lower bound is going to be 54. Here you go. But the upper bound is what? Because we don't know where it stops. It starts as from 54 and then it keeps going. So it's as if it converges towards positive infinity. All right, because it starts from 54, but we don't know where to end. So you'll need to put an approximation for infinity on the calculator. And the one I usually use is e to the power of 99 because that's a very big number. Okay, so the upper bound is going to be E99. Sigma is still going to be 5. And mean is going to be 50. It's the same question. And then execute. All right. So if you need to find an approximation for positive infinity, you can use you can use e to the power of 99. And here the answer is 0.212 because we need to give to 3 SFs, 1, 2, 3. But after the 1, you've got 8, which is more than 5. So it's going to round it up. In the same way, we can actually have a negative infinity. For example, if I need to work out probability x less equal to 55. So in this case, if I go back, so NCD, all right. So here the lower bound would be here. It's going to be because it's less equal to 55. So that's the upper bound, right? And then it goes up to minus infinity. So the lower bound here is going to be minus E99 because I said that E99 can be used as infinity. So minus E99 is going to be the lower bound. And then the upper bound here is going to be 55. So 55. The sigma is 5. The mean is 50 because it's the same question. Then execute. So that gives you 0.841 actually here because it's 8413. So the 3 won't round up the 1. It should be at least 5 for the number to be rounded up. So that's actually it gives you a good range of exercises whereby I showed you how to use NPD when it's x equal to something. And every time it's in the range, we use NCD, all right? And when you use NCD, it's going to ask you for lower and upper bound. This one is quite straightforward. It has a lower and upper. Here we have the lower bound. It starts as from 54, but it goes up to infinity actually. So as upper bound, we use E99 on the GDC. For this one, it was x less equal to 55. So the upper bound was 55, and then it goes down to negative infinity. So I used minus E99 as actually the infinity on the GDC. All right. One other thing the calculator can do for us is it can work out inverse normal distribution. Okay, and let me try to give you an example. So let's say we need to find the value corresponding to the 90th, okay, to the 90th percentile of the normal distribution. Okay, we need to find the value corresponding to the 90th percentile of the normal distribution. And the normal distribution has a mean of 100 and a standard deviation of 15. So what does that mean? It means that you need to find this value here. I'm going to call it A. So that it's the 90th percentile, meaning 90% of the data is actually below that value A. All right. So how do we do that? If you need to do that on your GDC, then you actually need to choose the inverse normal. So same thing, we go under normal, but we already tried NPD. I showed you what it means. We've tried NCD. Now we're going to use inverse normal. So you're going to press on F3, and it asks you a couple of things. It asks you about the tail. So the till means where is the area. So here the area is on the left hand side of A, so it's a left till. All right, and the area is the probability. So here the probability is 0.9, okay, because it's 90th percentile. Okay, let me write it for you. So it means x less than A is equal to 0.9. So the probability is 0.9, okay? And it's a left till because it's on the left. So left till on my GDC is 0.9. Standard deviation is 5, mu is 50, okay? It's the same question. And then you actually go on execute. And if you work it out, you see that you get x inverse is 56.4. So A will be 56.4. Okay, so 90% of the data is actually less than 56.4. Okay, and using the same logic, you can actually work out for a right tail as well. For example, you could have a normal distribution whereby you have A here and this is 0.25, let's say, and you need to find A. So what you do is you just need to go on your calculator and then try to put that information. So you go on distribution, F5, normal, inverse normal, and over here it's a right tail because that's on the right hand side. So you just need to change it here and then tell the calculator it's a right tail. And then the area would be 0.25 here, so 0.25. The sigma would be, I mean, if you use the same distribution, sigma will be 5 and then the mean would be 50. So you execute and that gives you A is equal to 53.4, okay, to 3SF. So you can actually do all these things using the inverse normal function. And you could actually have a third scenario whereby it's between two values, A and B, and let's say the area is 0.35. That could happen also. So then what happens is that the area is in the center. It's not a right tail, it's not a left tail. So you need to choose center here, which is F3. You say it's a center. You tell the calculator it's a center, then the probability is 0.35. You input that, and here you go. You execute. And in this case, it gives you two values, one for A, one for B. And from the diagram, you can see that A is the smallest value. So 47.7 is the value of A, and 52.3 is the value of B. All right, so you can see that the GDC is quite powerful. It can do lots of things. It can calculate individual probabilities for you. That's where we use the NPD. It can work out cumulative probabilities for you. It will ask you for a lower and upper bound. And the one we just explored here is that it gives you the probability and the calculator can actually use the probability to give you back the values. So that's where you use the inverse normal. Okay, so I hope that this video was actually useful to you.